Welcome, everyone. Quick show of hands. How many of you are running an Atlassian Connect add-on in the cloud today? Awesome. That's probably like 10, 20%. So I hope I can show you how you can save money and effort, maybe for your next add-on, or if you're planning to run an add-on for your next project today. So in the past, we've gotten used to the notion that our services run on servers. And there's been an evolution in this space. So we're no longer buying hardware and putting it into a closet, running it there, or not even anymore in a data center. So we rent virtual machines on AWS, Microsoft Azure, Google Cloud, and we run our services there. And with the arrival of Docker, things have actually gotten a lot easier and less expensive. So we can just run lightweight containers in a shared environment on shared resources. But all of those deployment options still have two major drawbacks in common. One of them is you pay for the resources regardless of whether your add-on receives any traffic. So you need to figure out what your capacity needs to be. You allocate that. You pay for it, whether you get traffic or not. So maybe you've just launched your Connect add-on in Marketplace and there's not much traffic anymore. Or you're running a marketing campaign and you need to make sure you have enough capacity to actually handle that peak after that. And you probably also not only have a production environment, but you also have a development environment, maybe a staging environment, so you maybe double or even triple that cost. The second drawback is you're not only responsible for the code that you run, you're also responsible for the environments that your code runs in. And what that means is you're responsible for updating base images and ensuring that everything is on the latest patch level to avoid security issues, you get the latest fixes. You need monitoring to keep an eye on capacity so you can scale up at the right point of time to handle those traffic spikes. So in summary, those two mean you have a lot of cost and you have a lot of effort. So in the next 40 minutes, I want to show you some techniques how you can avoid some of those drawbacks. And we're going to start with static add-ons. That's pretty much the simplest possible add-on that is still useful, that you can write, pretty much free to run. We're going to take that one step further because a lot of add-ons actually need some kind of storage, but I'm going to show you how you can do that without actually running a database. Even with those two options that take you a certain step down the way, you still have certain add-ons that require a backend. You need backend processing, you want to handle webhooks. So I'm going to show you how you can use AWS Lambdas and other techniques to do that. And I'm also going to show you how you manage deployment of these Lambda functions, because it's a bit different to what you're maybe used to with Docker containers or Chef, Ansible, and other deployment methods. So let's start with static add-ons. What are they? We all know static sites. So static websites, it's a bunch of HTML files, JavaScript files, CSS, that you can host very cheaply. There's many options. For instance, if you have a BitBucket account, BitBucket Pages is probably the simplest option to put some static files out there and serve them. You can serve them through a CDN that lowers latency for all of your consumers quite considerably and also kind of removes load on your backend. All of that is very well cacheable on the client side as well, because it's just static assets, so you can set cache headers. Browser doesn't even go back to the origin for that. So that's a very fast, very cheap experience. And static add-ons are actually taking advantage of that. You can think of it as an add-on that is just a static site hosted within a product. That by itself is not particularly useful. You can show static content in a Jira issue or on a Confluence page, but yeah, it's not going to be impressive. So what we offer here is an API that you can call from that static site, and that is pretty much what we refer to as a static add-on. That is a iframe. We call it the iframe bridge. It's a post-message protocol between the iframe and the host, and we expose a JavaScript API there that allows you to interact with the host. And that can mean purely client-side interactions. For instance, in HipChat, we allow you to open a room or open a user invite dialog, things like that. But you can also call the REST APIs of our products right from the browser. And you don't have to worry about authentication. We take care of that on the host side. And with those two options, you actually have quite powerful tools to write useful add-ons. And I want to show you an example that we've built in the past. It's a little image editor in HipChat, so you can select an existing image, and then you can modify that image in any way that you want. So you can annotate it in some way, and once you're happy with the result, you can apply those changes and share them back into the room, maybe add a little comment and share that with your coworkers. So all of that is built as a set of static files. There's absolutely no backend for that. And I'm going to show you how that's done. So this is the HTML. Pretty much everything in that add-on, because it's a React app, so we don't have a ton of HTML in our add-on. First of all, we need to include the connect host client library. That is the library that actually allows to call those host APIs in the first place. So it allows you to interact. And then for the heavy lifting, for the actual image editing, we use an image editor that Adobe provided. It's a component that you can use. And we have our own CSS and JavaScript just for our logic and gluing it together with HipChat. And I mentioned it's a React app, so we have a mount point. Everything is appearing under there. So that's our HTML file that we serve. As you can see, nothing dynamic here. And here's the core logic of our script there. I removed a bit of code, but essentially that's the add-on. There's a bit of boilerplate around it. And you can see that there's a call to actually register a callback for HipChat. So you can say whenever somebody clicks on that edit action, this callback is involved. If you've seen the Trello talk yesterday, that is actually quite similar to how we do it here as well. You receive the message that somebody selected. You can extract the URL, open the Adobe image editor, and once people are done editing, there's the other callback, the on-save button click being called. And at that point, we interact with HipChat again. So we get that image, and HipChat exposes a method to populate the input field with that image that you just edited. And then we close the editor, and that's about it. So a very simple way to write an add-on that actually looks quite powerful given the amount of code that we actually had to write. There are, of course, limitations that come with static add-ons. One of them, you don't have a backend, so you cannot handle the install payload that gives you the shared secret and all of that information. So you don't necessarily have control over who installs your add-on. And given that you don't get a shared secret at that point, there's also no point in handling all the JOT authentication that we put in the URL. So we recommend that you actually opt out of that. That keeps the JOT out of the URL, which improves caching. It's not a cache buster. And it also avoids an additional call on our end to actually generate that JOT. That also speeds up the experience quite a bit. The other limitation is you cannot handle webhooks. So if you're interested in kind of some message handling or Jira issue creation, things like that, you actually need a backend. And even though I mentioned that you don't get the shared secret and you cannot call API, you still need to declare the scopes for those add-ons because we keep checking them also for the client-side API and the REST calls that you make there. So those are the limitations, but if you don't need any of those modules, you actually get pretty far with static add-ons. This particular example is hosted on Aerobatics. Aerobatics is an Atlassian partner that allows static site hosting, and it's a bit more than just static site hosting. They actually provide pretty nifty tools around automatic asset versioning, so you can fully cache everything, and the next build of your asset leads to another URL that is embedded in that file. So you can fully cache, but you still have full control over your deployment cycle. They offer a CDN and SSL as well, which is a prereq to install something into our products. It's fully integrated in BitBucket pipelines. I do have an example later on where I show you how that's done, and it's free. So they have a free starter plan if you have like your add-on that you want to run. There's no cost to that. You get SSL, hosting, all of that for free. So perfect option for a simple add-on. In many cases, it's a bit too simple. So most add-ons aren't particularly useful if you cannot store any data. So I'm going to show you how to do that without actually running a database. We've built another example, this time in Confluence. We have seen HipChat before and now Confluence. The idea is to re-implement a macro that is quite popular for server, which is the page views macro for cloud. So if I select that macro and I put it on a page, save the page. It's going to take a while. Bear with me. Once the page is rendered, we see kind of the page views over time. So how many people looked at that page in the last couple of days, and also who were the last couple of viewers on that page. So obviously, in order to implement that add-on, we need to store that data. We need to store the views, and we need to store the users along with that page. The way you can do that in our products is by using content properties. Content properties, very simple key value store. You define a key, and then you can store any kind of value object with it. So in our example, we use that to store the views. So date, and we increase a counter every time. And secondly, we store the users that last visited that site. The way this works is I mentioned this iframe bridge, so you can interact with the host. You can call REST API there. So in this case, you call the content property REST API. And we have, for Confluence, we allow you to associate data with spaces, but also with any kind of other content, so typically pages and comments. And you can just do that using this small snippet. AP in this particular example is our host library. So in the previous example, we have just seen an alias, which was HipChat or HC, but it's the same library. And then you can use that AP request module to make those REST calls. In this particular example, we give you the content ID of that page. You can make that call with your key, and in the callback, you get that data back that we stored before. And similarly, whenever that macro is loaded, we can also record a page view. And in this case, I'm not processing, I'm just logging it out to the console, but the idea is that you would then render that data into a nice graph, purely client-side. The content API exists not in all of our products, but in many of them. So in Jira, you can associate data with issues, with projects, with users. And we also have an option to just store data globally for your add-on that is not associated with any particular artifact in our products. In Confluence, we allow you to store it with spaces, but any kind of other content, and content types are extensible in Confluence. Most often it's pages and comments, but you can define your own as well. And again, same as in Jira, we allow to store properties just for your add-on. And Trello has actually a very similar functionality as well. We don't have that currently in HipChat or in BitBucket. Given that we run our products in the cloud, there are some limits associated with that. We wouldn't want to allow you to store 2 terabytes of data in our instances. So per key, you get a 32K limit of what you can store. And in Confluence, at least, this is just limited by key, but you can use many keys if you want to. I think in Jira, I forgot the exact limit, but there's also a global limit on the data that you can store. If that's not sufficient, there's other options too. So in Confluence, you can define custom content types, and that allows you to structure any kind of store any kind of structured content, and you can then later render that. Additionally, we're also currently thinking about opening up our media API to external customers. That would allow you to store blob data as we do for our attachments and all of that. So we've seen like we can do static add-ons, we can store data, but now that's maybe not quite sufficient for what we want to build. And we do need a backend to handle webhooks. So I'm going to talk a bit about serverless add-ons. Serverless is not my favorite term, to be honest. I find it a bit misleading, but it's caught on quite a bit. So I'm going to use it here as well. It typically means one of two things. One of them is a backend as a service. So it's higher level services that you can just use, you pay for usage. Some common examples of that is Firebase, which is now Google, which allows you to store data in the cloud. You can publish, subscribe to that data. Quite a powerful service if you have, for instance, for mobile apps as well, but also for add-ons. Auth0 for identity needs, so handles login, OAuth2, things like that. PubNub for real-time messaging, presence, things like that. I'm going to focus a bit more on the second category, which is functions as a service. That's maybe something you've seen before. It's about running very short-lived backend code, and you don't pay for idle time. There are quite a few players in this area at the moment. So there's, I think the first one was AWS with the Lambdas, Microsoft has Azure Functions, IBM has OpenWhisk, Google has Cloud Functions, and also Auth0 that I mentioned before has web tasks, which is the same idea. And that idea is you deploy your code, but it's not running. Doesn't take up any time on any server, so you don't pay for it. Whenever there's an event happening, which could be an HTTP call, could be some other kind of event, your function is woken up, does its task, and then terminates, goes back to sleep. Next time the similar event happens, it's being woken up again, and if there's multiple consecutive requests, it actually stays up maybe for a minute or two and handles those requests before it goes back to sleep again. So that is very efficient to manage for all of those providers because they can fully leverage their infrastructure, which reduces the price for you that is actually running that code. It also means you don't have to manage infrastructure. You really, what I mentioned in the beginning, you only care about your code. You don't care about the environment that it runs in anymore. So AWS or any of the others is taking care of ensuring that the OS is up to date, everything's patched, and so on and so forth. You don't need to update base images, provision instances, any of that. In the context of serverless, sometimes you come across the word no-ops, so people see it as a way to totally forget about the operations aspect. Personally, I don't believe that's entirely true, but it certainly reduces the amount of monitoring, deployment tasks, and all of that you have to do. So I wouldn't quite say it's no maintenance, it's just lower maintenance. One of the biggest benefits I see of that way of running add-on is that it's very cheap to run pre-production environments. You have your dev environment, staging environment. They're hardly ever utilized, but you want to look them very close to production. And that is typically a pretty big cost factor if you go with traditional servers, because you kind of want to have a similar environment to production. In this case, you don't have a lot of traffic, you don't pay much. And elastic scaling is pretty much zero effort as well. You don't have to worry about what your scaling rules are and all of that. If you have more calls, there will be just more functions running in parallel, and you pay more. It's not only upsides, it's also downsides. So the tooling around these relatively new technologies is not very mature yet. So how to run this code locally and test it locally, there are various ways of doing that. None of them that great at the moment. For deployment, there are some relatively good options in the meantime, but also debugging these things in production is relatively hard, and there's not much tooling around it. And despite it being a cost saver, as long as you don't have a lot of traffic, it can become very expensive if you actually do get traffic. So at a higher scale, if you get a lot of requests and it's pretty much constantly running, it might actually be cheaper to run it as a Docker image. And you pay a startup penalty. So I showed your functions are idle, they're being woken up. That wake-up time can be anywhere up to 200 milliseconds, probably for all providers. It's not always the case. And as I said, they keep running, so most of the time you're fine. But there can be a bit of a penalty. So maybe not the perfect choice for very, very low latency guarantees. I prepared a few examples that I want to show you that actually illustrate how that looks like in practice. And all of my examples are based on a framework, which is also called Serverless. Not quite surprisingly, it's a small company based in Oakland, California. They launched maybe a year ago, I would say. 1.0 was maybe half a year ago. And it's actually a pretty cool framework because it allows you to deploy to various providers of these Lambda functions. So AWS was the first one, but they also support OpenWhisk, Azure. And also in terms of language, you're quite flexible. They support Node.js. You can write your functions in Python or in Java. So my first example that I want to show you is a small bot I wrote for HipChat again. So it's a Wolfram Alpha integration. Not sure if you're familiar with that. It's pretty much a knowledge search engine. So that bot tries to answer any questions you have. So a couple of real examples here. Can answer how many inches there are in a meter, or stock price of Atlassian, flag of Australia, anything you don't know, you can ask the bot. Maybe you get a reply. In this case, I used AWS Lambda and the AWS API Gateway. And kind of the core blueprint of how that works is I type something into HipChat that triggers a webhook, which goes through API gateway, gets translated into an event that my Lambda implementation can handle. I call the Wolfram API, and I send a response back to HipChat. I want to quickly show you the project structure of such a serverless project. So there's a descriptor that tells the serverless framework what I want to publish to AWS, and we're going to see that on the next slide. I need to have my actual function. So in this case, I use Node.js. So this handler.js file is where my implementation lives. Then there's obviously some business logic I need to transform and interact with the Wolfram Lambda API, some more configuration, deployment artifacts, test data, and test helpers, all that much. But the core is actually in this handler.js and in the serverless YAML. That file is shown here. So you see I declare the entry point. I have my handler.js, which is this handler fragment here. And my function in there is called Wolfram. This is what's being invoked when my Lambda is being invoked. There are some other things in here. I can say I want to deploy to AWS. It's Node.js, US West, and so on. And I say my function lives at /Wolfram. That's the path, and it's a post, because I want to handle a webhook. And I say, what are my constraints? I have a timeout of 10 seconds for this add-on, and memory is typically not exceeding 128 megs, so I can declare that here. Those are kind of the limits that my Lambda has. And it's also important to know that this is what you're built for, so the combination of that two. How long do you consume memory, pretty much? So keeping them low is important. They're relatively high here, because the Wolfram API has a pretty high latency, so that I kind of need the 10 seconds. And we can exclude some files. So here you see the actual implementation. It's this handler.js file. There's a Wolfram function. This is what I declared. This gets invoked. I can parse the webhook, extract the message, then call the Wolfram API with that text, process the results, and then send a reply to HipChat using the results that I got from there. And that's pretty much it. I did remove a bit of error handling here, but otherwise I haven't cheated. So this is literally the entire function that implements this add-on. Let's look at how much that costs. If you would run that, I say 2,000 calls a month. I just want to run that within my company or within my team, so it's not something on Marketplace. This is also the free calls that I get to the Wolfram API. And I assume about 10 kilobytes of data per call, because that's what the API gateway is billing on, kind of transfer. In this case, any guesses? 1 cent for the entire thing. And so I can run that in my team, don't have to worry about. We can use it whenever we want. Now, maybe for a more realistic example. So that was a simple bot, works great. I'm using Lambdas. My second example is BitBucket's activity graph. So it's a calendar heat map that shows commit activity over time. You've probably seen very similar UI in GitHub. In this case, we use a bit more. So we have a UI. Again, we host that on Aerobatic. All of our static assets are there. We use AWS Lambda and Gateway again. And we also need to store some data. So in this example, we actually use AWS DynamoDB to actually store all of that data. And here's a quick overview of how that's implemented. So whenever I push to BitBucket, it triggers a webhook that goes through Aerobatic, through API Gateway to my Lambda implementation. And I can record that commit. I just increase a counter for that particular repository and for that particular day. And we'll see, you might wonder why this is going through Aerobatic. I'm going to solve that question in a second. So this is invoked on every commit. And now every time you visit the repository page, we actually want to render that data. So there's a second endpoint that is just delivering that data out to the UI. So Aerobatic serves all the assets, static assets around it, including that component that renders the calendar. And there's also a call that actually goes back to my Lambda, which fetches the data from DynamoDB and returns it to the UI so that I can render it there. So that's, in a nutshell, what we're building with this add-on. Again, there's a serverless descriptor. In this case, we register 2 functions. One of them is returning the data or the activity. That's the first one, the activity one. The other one is on push. That's the webhook handler. One of them is get, one of them is post. Everything's declared in here. And for Dynamo, there's actually no abstraction here. This is just plain CloudFormation syntax of AWS, how you declare a table to actually store that data. So that is our description for AWS, pretty much. We need a connect descriptor to actually wire these things together. So here I declare a base URL in my standard Atlassian connect descriptor for BitBucket. And this is actually an interesting little detail for Aerobatic. If you use that __ base URL variable in there, Aerobatic will automatically replace it when it serves that descriptor. And that allows you to run the same code in multiple environments, and you get different base URLs for the different environments, which makes it, you don't have to handle that in your build scripts and all of that. It's just automatic at runtime. Very convenient for that use case. And now it also becomes clear why those calls go to Aerobatic first, because the base URL is different, and everything is relative to the base URL, so we cannot have 2 URLs, one for the static assets and one for the lambdas. So we need one base URL, and that's why everything gets routed through Aerobatic. I declare my webhook standard module for BitBucket. I declare my web panel that shows up on the repository page, which is a static page that makes Ajax calls back to the Lambda. And I have a separate file for Aerobatic. So that was kind of for the AWS Lambda declaration. For Aerobatic, I declare a little file that is actually for the proxying. So given all of those calls go to Aerobatic, I need to proxy them through to my Lambda. And fortunately, Aerobatic has a plugin for that. And I just need to declare my 2 paths and then say where they point to. And I can even add some cache headers, because that data doesn't need to be up to date all the time. So if that's a minute old, there's not so many commits on that repository, and it's just a green color, which is a bit brighter, a bit darker. I can cache that, and that also reduces calls to my backend, further lowering cost. So it works quite nicely together. My implementation, you don't have to pay pay a lot of attention to the actual implementation. But again, again, you see kind of the 2 endpoints, the activity function that is just loading the data from Dynamo, and the onPush function that is storing that data to Dynamo. So that's pretty much my add-on from a Lambda perspective. Again, not much code. There's a bit more backend, so there's kind of the storage layer for Dynamo. There's a bit more code there, but those are pretty much my Lambdas. If we look at that example, and we assume it's on Marketplace, and so we have a lot more views per day. I assume 100,000 views per day maybe. I have to handle 20,000 commits a day. And the data size is actually relatively small, so those webhooks aren't particularly big, and the data that I need to retrieve, it's very small. It's really just like a couple of dates and a number. So maybe about 1 kilobyte per call. Any guesses for this one? It's about $15 a month at that rate that I would pay for this add-on. And again, keep in mind, all my dev and staging environments, they're pretty much for free, because there's not much traffic besides my testing, which is way lower than what I have here in numbers. All right, so now we have seen how that works in terms of declaration and code and all of that. But how do we manage those lambdas in a real environment? So if I work on them with a team and I need to deploy them, how do I manage that? I'm going to show you how I did that with BitBucket pipelines. And I want my deployments to be automated, so I don't have to do anything. Everything works on every commit. So run all my tests on every branch. If I merge something into master, I want that deployed to my dev environment, and I want a manual promotion to production. I definitely want them to be reproducible, so I don't want to build something locally and push that out to production because maybe my node modules directory is a bit out of date, and any of those things that can happen. And I want it to be safe as well, so I want to go through multiple stages, and I want an easy way to roll back if something goes really wrong. So any branch is just being built and tested, no deployment happens. Master is built and tested, deployed to dev. And it's a manual step to say, okay, I'm quite happy with that build. Now I want to push that out to production. That's kind of my goal, to deploy that add-on. Again, more YAML here, this time for BitBucket pipelines. We see here the BitBucket pipelines configuration for pretty much anything is just npm install, npm test. That's my build and test step. That is happening for every commit on every branch. There's a specific configuration for master, and in this case, I install both the Aerobatics CLI and also the serverless CLI, so I can actually do the deployment later. Again, I install, test my add-on. Once I'm happy, I can actually deploy that. My custom step is kind of the production step. That's a manual trigger that is declared separately, isn't automatically run. But I go through the same steps there for now. There are probably better ways of doing that. So optimally, I would actually build an artifact and then deploy that artifact. Serverless has actually added support for something like that a couple of days ago. It was a bit too late to update my slides. I'm pretty sure there's now a better option to do that. The nice thing is also that both Aerobatic and serverless deploy stages, so that allows me to deploy to my dev environment or to my production environment by just specifying a command line parameter with my stage name. So now I have my build setup, so any commit gets tested, any commit to master gets deployed to dev, and my custom step actually deploys to production, so same steps as here without the stage parameters. And these stages, they manifest themselves in Aerobatic by a different suffix in the URL. So my add-on runs on BB activity graph def or on BB activity graph, depending on where I deploy to. And as I mentioned before, with this nice little placeholder, double underscore base URL, my base URL actually gets automatically replaced in those descriptors. Everything points to the right location. There's no suffix for production. So how does that look like? When I run any kind of branch, you can see it goes through the build setup and runs the test step. Everything's successful in this case, but there's nothing happening besides that. For master, it looks a bit different. So you can see that we now run all of these deployment steps as part of BitBucket pipelines, and it's automatically being deployed to dev, prints out those URLs where it was actually deployed to. So all of that is working, but now if you think back, I mentioned this routing through Aerobatic. So now we have Aerobatic deployed on a dev URL and on a production URL, but now I need to make sure that they actually point to the right lambdas in the backend, to my dev version and to my production version. And I've shown you the Aerobatic YAML earlier with this declaration of the proxy configuration, how to proxy these calls through Aerobatic with those API endpoint variables. And this is where everything comes together at this point. So I can go to Aerobatic and say, for my dev environment, my API endpoint points to this lambda, and for the production endpoint, it points to the other one. Now we have everything correctly wired together, so you have your two Aerobatic URLs for the descriptor and all of your UI. All the calls go there. They get routed to the correct lambdas in the backend if you call them, and our deployment is managing one side or the other. And so that's a fully functional dev environment, production environment, and automatic deployments for them. So I think these two tools work really well together. Lastly, now that we have that, I can actually go to every commit and press the Run Pipeline button. That allows me to select my production deployment. And I just click Run, and that kind of kicks off the production deployment of my Lambdas for that particular commit. So if I wanted to go back to an older version because I screwed it up, then I can just go to the previous good commit and push that button. There might be a couple of nicer options, but it actually ticks pretty much all of the boxes that I wanted to fulfill. So once I run that, everything is deployed, and this is kind of a bit self-referential, but that is actually my repo that hosts this activity, that activity graph add-on, which hosts itself, and I've just deployed there, and everything's still working. We have all of those examples ready for you, so they're all on BitBucket in our account. So Klaus Ilberg also works at Atlassian, has written the Confluence one, I've written the HipChat and BitBucket ones. So you can check out the full code base, you find all of the code and configuration there, and maybe you find some inspiration. All right, I hope that was helpful. Thank you very much for listening, and thanks.